Welcome to class 11th maths classes. Okay, today we'll learn sequences and series. Okay, this is mainly from the NCERT book. So what we are going to learn is these are the topics: introduction, sequence and series, then exercise, then what is arithmetic progression and geometric progression. Even though in the NCERT book only they gave about geometric progression, and mostly almost all the problems are about geometric progression. Okay, but we learn both. Okay, and exercise, more exercise. And then actually that's all for the NCERT class, but I want to add harmonic progression because in any of the engineering entrance exams, you will get all the three actually: arithmetic progression, geometric, and harmonic progression. So let's learn some basics of it. When we solve the problems anyway, all three tricks and threads I will teach anyway. Okay, so let's get into the sequences and series. Okay. So first, let's understand the definition. What is a sequence? Sequence is just a ordered list of numbers. Okay, ordered list of numbers means if you have a number like 1, 2, 3, 4, 5, 6, then we can call it it's a sequence, right? And in that term, each number is called a term. Okay, so first term, second term, third term, last term, nth term. Okay, so like that, and they are all the sequences mainly they are bound by some rules. Okay, sequences are mainly used for the growth, depreciating values, etc. All those that's where we use actually. Okay, sequence with a pattern is called a progression. Okay, now sequence can be anything. The rule can be simple. Okay, any rule. Okay, but when you have a proper rule set, then it's called progression. Example. Okay, 1, 2, 3, 4, 5, 6, 7, 8. I said it's a sequence. It's a sequence as well as progression because alternate numbers there is a difference of only one. Correct? There is a common difference of one between any two consecutive numbers. Okay, so it's a progression also. Okay, but let's take you have a number 1, 2, 3, 4, 7, 8, 2, 7, 8, 5, like that. Suppose. Okay, that is just a sequence. It's just a sequence. It may be repetitive, may not be repetitive, but it's a sequence, finite or infinite. Okay, so understand the difference between a sequence and progression. Sequence is basically a set of numbers, ordered numbers. Okay, progression is a pattern. Okay, you can actually repeat the pattern. Okay, now sequence are denoted by A1 to A2, A up to AN. Finite sequence will have limited terms. Infinite sequence will have infinite terms. Uh, General term of often written using a formula, okay, of AN, but it need not be true for a sequence. It's mostly for the progression, okay, as I said. Okay, suppose you take a Fibonacci sequence, okay, I can call Fibonacci progression, but it's a Fibonacci sequence is A1 and A2 are first two terms are 1, and then AN, the general term, is defined as sum of previous two terms. Sum of previous two terms, that is AN minus 1 and AN minus 2, right? So this is how we define a nth term using a general formula like this. Okay, what is a series? Okay, series and sequence progression, there is not much difference. Okay, series is basically sum of the terms of a sequence is a series. Okay, finite series will have a finite number of terms. Again, infinite series will have indefinitely, continuous indefinitely. So you represent a series with a sigma notation. Okay, sigma k equal to 1 to n if you call. Okay, and a of k, which means if you substitute k equal to 1 to n, you will get a1, a2, a3. That is a sequence. And if you add a plus, because it's a sigma, right? It's a sigma, so plus sign you will put. Okay, so a1 plus a2 plus a3 up to an. Okay, so this is called a sigma notation. Similarly, you have a pi notation. If it is pi k equal to 1 to ak, then it is a product of all the terms. Okay, a1 into a2 into a3 into up to an. Okay, so remember pi also, though I did not mention here. Okay, so this is what the basic definition of sequence and a series. Very simple theory in this chapter actually. You just go and solve the problems because your 10th class knowledge is more than enough for this. Okay, okay, let's get into the exercise. Write the first 5 terms of each sequence in exercise 1 to 6. Okay, so an is given as n into n plus 2. Okay, so we can just substitute n equal to 1, then you will get a1. a1 is 3, a2 is 12, a3 is 15, a4 24, and a5 is 35. Okay, so this is the you will write all these questions. Okay, up to 1 to 6. I'm not going through each and every one, but you can do it yourself. Okay, so this is not actually A into N, it is I mean subscript here actually. Okay. Okay. Find the indicator terms in each of the sequence from 7 to 10. Okay. an equal to 4n minus 3 and a17 and a24 you want to find. Okay. Not the first five terms. So this is also straightforward. A17 you replace n with 17 you will get. So like if you take this one, an equal to 4n minus 3. So a17 is 4 into 17 minus 3. You just replace n with 17 which is 65. A24 4 into 24 minus 3 which is 93. Okay. So similarly you will do for all other problems. Okay. Next. Uh, in this question, he is asking first five terms and then corresponding series. Okay, I'll just show you one of them. 11th one, if you see, a1 is given as 3 and an is given as equation 3 times an minus 1 plus 2. Okay, so your first term, you know, already it is 3. Second term you will get is you substitute the first term here. Okay, so 3 into 3 plus 2, which is 11. Okay, this will become 11 into 3 which is 33 plus 2 35. Okay, like that you will write. Okay, these are the first five terms and the series you will represent using plus sign in between. Okay, so this is the series 3 plus 11 plus 35 plus 107 plus 323, and we don't know how many terms are there, so I just put dash dash dash. Okay, so this is how you will do all the problems here. Okay, so yeah, this one is the Fibonacci sequence is defined as a1 equal to a2 equal to 1 and an equal to an minus 1 plus an minus 2. Okay, n is greater than 2. Now find an plus 1 by an for 1, 2, 3, 4, 5. Okay, so this is first thing is you form the Fibonacci series. You need at least six terms, right? So you form the six terms here because n plus 1 is there, right? Find n plus 1. Okay. So first six terms are 1, 1, and sum of these two, which is 2, sum of these two, 2, 1 plus 2, 3, and 2 plus 3, 5, then 3 plus 5, 8. This is your Fibonacci series. Now, simple, you just make a table like this. Okay, n, what is the value of n, and then an plus 1 by an, okay, and the result. Okay, so for 1, it is 1, for 2, it is 2, for 3, it is 3 by 2, for 4, it is 5 by 3, for 5, it is 8 by 5. So something like this, it goes on. Okay. So yeah, these are the set of problems in exercise 8.1, which is very, very simple, and I don't think you should take more than 5 minutes for this. Okay. So let's get into the next topic. Okay. So this is where we learn about the arithmetic progression and geometric progression, which is you already know in 10th class, 9th class, right? So arithmetic progression sequences you write like this: a comma a plus d plus a plus 2d plus a plus 3d, where there is a common difference of d between subsequent terms. Okay. First, we'll read about arithmetic progression, then go to geometric. Okay. Then common term is a plus n minus 1 into d. So if you see second term has 1d, first term has 0d, third term has 2d, correct? So every time, whatever is the number of the term, tn, then you get n minus 1d, okay? Plus initial number, initial term. Okay, so a plus n minus 1d. Okay, and then common difference is difference between two terms, that is tn plus 1 minus tn. Okay, it is very important to note down what is your tn. Okay, common term. Most of the questions in engineering entrance are asked based on common terms. Okay, so your tn, how to form the tn is very, very important. Okay, then sum of terms is given as n by 2, which is number of terms by 2 divided by 2 into 2a plus n minus 1d. Okay, otherwise n by 2 into a plus l. Okay, here l is the last number. If you know what is the last term, then first initial term, last term, sum of them, and then product multiply with n by 2, you will get the sum of the series. Okay, so this is the sum formula. Middle term is if ABC are in AP, then B is equal to A plus C by 2, which is the average, right? And it is also true if you have first term and fifth term, the average of those two also B. Okay, then first term and so like that, you take 2 before 2 after, you still get the same value. Okay, so be careful with that. Okay, that is very useful for many of the arithmetic progression problems. Then mean, arithmetic mean of any numbers you give. Okay, you are given n numbers, then sum of all the numbers divided by n is arithmetic mean. Okay, and yeah, for a and b, if you take two numbers, then arithmetic mean is a plus b by 2. If a b c, then a plus b plus c by 3. like that. Okay, so I'll come to this one later. So next is geometric progression. Geometric progression is represented as AR square, AR cube. So you see that each term there is a multiplication factor of R. So R is called common ratio. Okay, common ratio, which is nothing but a division of two terms basically. Okay, second term by first term always. Okay, and the common term is a into r to the power of n minus 1. So here also you see the power is 1 less than the term number. Okay, so a into r to the power of n minus 1, where r is the common ratio. Okay, and then sum of geometric progression is, if you for n terms is a into r to the power of 1 minus r to the power of n minus 1 divided by r minus 1 if r is greater than 1. If r is less than 1, then it is a into 1 minus r to the power of n divided by 1 minus r. Okay. So, and ABC, if they are in GP, then B is equal to, that is middle term equal to square root of product of two neighboring terms basically. Okay. So B is equal to square root of AC. Now, geometric mean of terms is nothing but same. Nth root of product of n terms. If there are n terms, let's take ABC at the three terms, then geometric mean of ABC is ABC to the power of 1 by 3. That is cubed root of ABC. Okay, so here AB, then it is square root of AB. Now, this is arithmetic mean is always greater than or equal to geometric mean. Okay, this is one very, very important thing to note. Okay, and most of the inequality problems we will solve using this arithmetic mean greater than geometric mean greater than or equal to. Okay, this has an extension. I will explain that in one of the videos later. Okay, but note down this one. And when you know about harmonic mean, right? HM. So arithmetic mean is greater than or equal to geometric mean greater than or equal to HM. So you note down this. And this equality holds good only if all the terms are same. Okay. If all the terms are a equal to b, only then a plus b by 2 is equal to square root of ab, aa. Okay, ab, or since ab are same, it will become a equal to a. Okay, so note down that one. Equality is possible only if the terms are equal. Okay, so note down this one. Let's get into the some problems. Okay, solve all these NCERT problems. Very important to before going into the your big books actually of all the JEE and engineering entrance books. Okay, the more complex problems you will see there. But before going to that, first brush down your theory part and uh, okay, without any mistakes, solve all the problems. Then you go into the real JEE problems or BITSAT problems. Okay, let's get into exercise 8.2. Yeah, the first question is to find the 20th and nth term of the GP. Okay, given here. So first thing is either you can directly find the nth term and then substitute n equal to 20. Okay, that is one way. So common ratio is first thing you need to find out any GP or AP is common ratio or common difference. Okay, that is the first thing. Once you have that one and first term, then you can do anything you want, right? So common ratio here is 5 by 4 divided by 5 by 2, which is reciprocal uh, 2 by 5. Okay, so which is equal to half. Half is the common ratio. So once I know half is the common ratio, my nth term is 5 by 2, which is A, right? A into r to the power of n minus 1. So 5 by 2 into 1 by 2 to the power of n minus 1, which is 5 by 2 to the power of n. Now I can replace any number I want. Okay, n equal to 20, I'll get 20th term, which is 5 by 2 to the power of 20. Okay, find the 12th term of a GP whose eighth term is given and common ratio is given. Okay, so common ratio is 2, eighth term is a into r to the power of 7. This is what your eighth term of a GP, which is 192. So you, since you know r, you can get the value of a. Correct, a is equal to 3 by 2. Once you know a and r, you can find any term. Okay, now you need a 12th term. So 12th term is nothing but a into r to the power of 11, which is 3072. Okay, fifth, eighth, 11th terms of GP are P, Q, and S. Okay, then show that Q square equal to PS. Okay, so if you see 5, 8, 11, okay, there is a gap of 2, right? 6, 7, and 9, 10. That means they are just like neighbors only. Okay, exactly same rule applies as neighbors. Okay, so we can easily prove this. Fifth term is nothing but A into r to the power of 4. Seventh term is nothing but A into r to the power of 7. Okay, and 11th term is nothing but a into r to the power of 8. Correct? So LHS is q square, which is taken. Q square is nothing but a into r to the power of 7 whole square, which is a square r to the power of 14. And which is equal to, I can rewrite this as a into r to the power of 4 into a into r to the power of 10, which is nothing but PS. Okay, so this is nothing but RHS, so proved. Okay, so note down this one. Okay, if A, B, C are in GP, B equal to B square equal to AC, correct? Now, if A, B, C, D, E, A, B, C, D, E, 5 terms are in GP, okay? So, middle term C is equal to the neighboring, which is B and D, right? C square equal to BD, also C square equal to A and E also, okay? The exactly similar distance, terms which are exactly similar distance from the given term are also form a geometric mean, okay? So, note down this one. Fourth term of a GP is the square of second term and the first term is -3, okay? Determine the seventh term. Okay, so what is given is a equal to -3 first term, fourth term t4 equal to a into r to the power of 3, t square equal to a into r to the power of 1. Okay, so t power 4 is given as t2 square. T4 is given as t2 square. So which is, if I put the values here, -3 into r cube equal to -3r whole square. If I solve for r, I get r as -3. Now seventh term is simple. I have a, I have r. Seventh term is nothing but -3 to the power of 7. Okay, yeah, next. Which term of the following sequences is the given term? Okay, this is simple. We'll do one problem. So sequence is given here 2, 2 root 2, 4, and then which term is 128? So you are basically checking t of n, which is equal to 128, Tn is 128, a is given as 2, r is given as 2 root 2 divided by 2, which is root 2. Okay, now you have a and r, you have Tn, you need to find n. Tn is nothing but a into r to the power of n minus 1, which is equal to 128. Okay, now you write it in the proper way. The LHS side becomes 2 to the power of n minus 1 divided by 2, which is equal to 2 to the power of 6, which means n minus 1 equal to 6 into 2 or n equal to 13. 13th term is 128. Okay, so this is how all these problems will be done. So same fashion, you can do it. Okay, now for which values of x the numbers -2 by 7, x and -7 by 2 are in GP. Okay, so if three numbers are in GP, you can apply a geometric mean, right? Which is nothing but x square equal to product of neighboring numbers, neighboring terms. So which is simple. So x square equal to -2 by 7 into -7 by 2, which is 1. So x equal to plus or minus 1. Okay, next. So it can form actually two series, -2 by 7, 1, -7 by 2, or -2 by 7, -1, -7 by 2. Okay. Find the sum to indicate number of terms in each of the geometric progression to in 7 to 10. Okay. So series is given here. Geometric progression or geometric series is given 0.15, 0.015, 0.0015 up to 20 terms. Okay. So you know what is your A? A is nothing but 0.15. Okay. R is nothing but 0.015 divided by 0.15, which is 0.1. R is, so you have A, you have R, you have n is 20 terms, so s20 equal to, you have to apply this formula, right? Since it is less than 1, since the common ratio r is less than 1, you will apply 1 minus r to the power of n divided by 1 minus r. Okay, if you simplify, approximately you'll get 1 by 6. Okay, so all are same problems. Okay, you can just do it yourself, similar. Okay, 9th and 10th all are same. Okay, so 10th one is a generic one. Okay, if you see here, it starts with x cube. So a is x cube, r is x square. Okay, so you substitute values properly, you will get the answer. Okay, evaluate sigma k equal to 1 to 11, 2 plus 3 power k. Okay, so this is just, first thing is expand the sigma value. So sigma is applied to the 2 as sigma of 2 and sigma of 3 power k. Sigma of 2 is nothing but n. Okay, whatever is the k goes from 1 to 11, you just add plus 1 plus 1 plus 1, right? 2 into, if I take 2 out, it is just plus 1 plus 1 plus 1 plus 1, which is nothing but 11, right? 11 times, so 11. So 11 into 2 is this one, okay, which is 22. And here it forms a geometric progression, okay, which is 3 plus geometric series, you can call 3 plus 3 by 2 plus 3 square plus 3 cube up to 11 times, okay, because k is running from 1 to 11. Okay, so this is nothing but I apply the sum of geometric progression formula here. So this is my answer, 22 plus 3 by 2 into 3 to the power of 11 minus 1. Okay, that's the answer. Next. Okay, The sum of first three terms of a GP is given and their product is 1. Find the common ratio and terms. Okay, so this is simple. So all such questions, okay, when they are giving sum of first three terms are in a AP, okay, or product of continuous terms, three terms or five terms in a GP, you always take numbers like this because product is 1, I know, right? So I take my first three terms as A by R, A and AR. Okay, this is also there also in GP with common ratio as R, correct? So by taking this one, product of these three numbers becomes A cube. So A cube equal to 1, so I already got my A, right? My first term already I got. So all such terms, you please use something like this. You can also get answer if you take A, AR and AR square, you will get the answer. There is nothing wrong. Okay, but this is a better one. If five terms are given, seven terms are given, then the addition goes very complex, right? Addition or multiplication goes very complex. So this is how we should do. Okay, when it is three terms, five terms, when the product is given, then this is how we should do. Okay, so product equal to 1, which means A cube equal to 1 or A is 1. Okay, now sum is 1 by R plus 1 plus R. Okay, which is nothing but because A is 1. So I am not taking A by R, A plus AR, right? So I am not taking A because A is equal to 1. So which is nothing but R square plus R plus 1 divided by R equal to 39 by 10. So I'll get a quadratic equation, something like this. Okay. And once I get this quadratic equation, simplifying is easy. So I'll get 5R minus 2 into 2R minus 5 equal to 0. So R equal to either 2 by 5 or 5 by 2. Okay. So I get my first three terms as 5 by 2, 1, 2 by 5 or 2 by 5, 1, 5 by 2. Okay. So the important thing about GP is if GP is written from 1 to n, the common ratio is R. If you write the same GP from n to 1, reverse order, common ratio will become 1 by R. So that's what you can understand from here, right? Here R has two values, 2 by 5 or 5 by 2. Both are reciprocals. So both reciprocals actually give same terms in the GP. The series will be same. Okay. Some series, everything will be same basically. Only thing is the order of the progression will be reversed. Okay. So note down this one. Yeah. Next. How many terms of GP 3, 3 square, 3 cube are required to give a sum of 120? Okay. So basically sum is given. First term is given, common ratio is given, you just need to find n. Okay, so substitute the equation Sn equal to a into r to the power of n minus 1 divided by r minus 1. You have all the information, you just need to solve the equation. Okay, next. The sum of first three terms of GP is 16 and sum of next three terms is 128. Okay, determine the first term common ratio and sum to the nth term. Okay, so what is given is S3, S3 is 16, which is given, and S6 is not given exactly. Okay, but S6 is nothing but first three terms or next three terms, that is 16 plus 128, correct? So you have two equations. Now you divide them, S6 by S3, okay, which you will get r to the power of 6 minus 1 by r to the power of 3 minus 1, okay, which is equal to 144 by 16, that is 9. Okay, so you get a quadratic, equation here, polynomial equation here, r cube plus 1 equal to 9, or r cube is 8, or r equal to 2. So now you got the common ratio, which is 2. Substitute in any of the equations, you will get the initial term. Okay. So if I substitute here, a into 2 to the power of 3 minus 1 by 2 minus 1, which is 16. So a is nothing but 16 divided by 7. Okay. So now once I know a, I have common ratio, correct? Initial term, common ratio, and all the required information is it. So Sn, sum of nth term is 16 by 7 into 2 to the power of n minus 1 by 2 minus 1, which is nothing but 16 by 7 into 2 to the power of n minus 1. Okay, next. Given a GP with A equal to, that is initial term equal to 729 and seventh term is 64, determine S7. Okay, sum up to seventh term you need to find out. Okay, so this is simple. You have A1 which is 729, A7 is 64, A7 is nothing but A1 r to the power of 7 minus 1, which is r to the power of 729 into r to the power of 6, correct? So which is 64. Now don't do a mistake here. Okay, one mistake we'll do is we will just take r as 2 by 3. Okay, r has two values. R is plus or minus 2 by 3. That is the correct one. Okay, so you have to consider r 2 by 3 and r as minus 2 by 3 and then find the series. Okay, so you have a, you have r. So for r equal to 2 by 3, if you substitute S7, you will get a total of 2059. If for r equal to minus 2 by 3, and S7 you will get 463. So these are two answers. Okay, don't do a mistake. Next, find a GP for which sum of first two terms is -4 and fifth term is 4 times the third term. Okay, so yeah, this is straightforward. Okay, A1 is A. I'm just assuming A2 is nothing but AR. A5 is AR power 4. A3 is AR square. Okay, now given information is A1 plus A2 equal to -4. A5 is 4 times A3. Okay, so from this one, A5 equal to 4 times A3, you will get R value. Okay, R is nothing but plus or minus 2. So again, you need to consider both values and solve the problem. For plus 2, R equal to plus 2, A plus AR equal to A plus 2A, okay, which is equal to -4, or A equal to -4 by 3. So now you can construct a GP with A and R. Okay, similarly, you take R equal to -2, you get the value A as initial term as 4. So you again construct a GP with this information. Okay, next. The fourth, 10th, and 16th terms of a GP are XYZ respectively. Prove that XYZ are in GP. Okay, this is a straightforward question. You take just the values. A4 will be X, okay, which is nothing but AR cube. A10 is Y, which is AR to the power of 9. A16 is Z, which is AR to the power of 15. Now for three terms to be in GP, you need to prove that Y square equal to XZ or Y by X equal to Z by Y, right? So let's take Y by X. Y by X is R to the power of 6 and Z by Y also R to the power of 6. That means X, Y, Z are in GP. They have same common ratio, so they are in GP. Okay. Next. Find the sum of n terms of sequence. This is given. This is a very common problem which will come in series. Okay. So do it one time, then all are same type. Okay. So first thing is Sn equal to 8 plus 88 plus 888 up to n terms. Okay. Sn by 8, if I am dividing the series by 8, then what I will get is 1 plus 11 plus 111 plus 1111, okay, up to n terms. Okay, now I am multiplying the series with 9. Why I am doing all this? Okay, why I am doing all this is I need a GP. Okay, I need to get a GP in this n terms. Then I can apply my formula. Okay, so 9 times this Sn by 8 is nothing but 9 plus 99 plus 999 up to n terms. So 9 I can write as 10 minus 1, 99 I can write as 100 minus 1, 1000 minus 1, and so on. So if you see here, there are n minus 1s, so that is minus n, and then I have 10, 100, 1000 n times. Okay, so this is a geometric progression with the initial term as 10 and common ratio as 10. So 9 Sn by 8 equal to, okay, this GP, sum of geometric progression minus n. So this one is nothing but 10 into 10 to the power of n minus 1 by 10 minus 1 minus n. Okay, so if I simplify, what I'll get Sn is 80 by 81 into 10 to the power of n minus 1 minus 8n by 9. Okay, so this is a very, very common problem which comes in geometric progression. I'm sure in your 11th or intermediate exams, you will definitely get a question on this problem. Okay, next. Find the sum of the products of corresponding terms of the sequence 2, 4, 8, 16, 32 and 128, 32, 8, 2 and half. Okay, so what you have to do is there are two series given. You have to construct a new series, okay, sequence 1 and sequence 2, new series, which is corresponding terms product. So 2 into 128 plus 8 into, 4 into 32 plus 8 into 8 plus 2 into 16 plus half into 32. Okay, this is a very straightforward question. You sum up, you will get 496. Okay, next. Show that the product of corresponding terms of the sequence, okay, two sequences form a GP. Both are in GP, right? So we have a theorem already based on this. If you are multiplying the corresponding terms of two GPs, the new sequence also in GP. Okay, so we'll just prove it. That's very simple. One is this one, AR square, and other one is capital A, capital AR square, and so on. New sequence will be A into A, okay, AR into AR, AR square into AR square, and so on. So if you see, the first term is AA, which is common in all the terms, okay, and each term is multiplied by RR. RR square, RR cubes. That means common ratio is RR. Correct? So the newly formed sequence also series also is in GB. Okay, common ratio is R, small r into capital R. Next, find the number of numbers forming a geometric progression in which the third term is greater than the first term by 9 and the second term is greater than the fourth by 18. So you just need to properly put the equations, then you will get the answer very easily. Okay. First four terms, these are the first four terms. So AR square minus A is given as 9, AR minus AR cube is given as 18. Okay, so if I take A common here, it is R square minus 1 is 9. If I take AR common here, 1 minus R square into 1 minus R square is equal to 18. If I divide them, basically I will get R equal to minus 2. Okay, now substitute in any one of them, you will get A is 3. Okay, now sequence you can form with the A and R. Okay, next. The pth, qth and rth terms of a GP are ABC respectively. Prove that. Okay, a to the power of q minus r into b to the power of r minus p into c to the power of p minus q equal to 1. Okay, so all such problems very simple actually. You already know it's a GP. Okay, in a GP, pth term is nothing but, let's assume that initial term is k and common ratio is m. Okay, because r you cannot take, rth term we are calling, so let's take something else. Okay, common ratio is m. So pth term is nothing but k into m to the power of p minus 1, okay, which is a. Now qth term is k into m to the power of q minus 1, which is b. Rth term is k into m to the power of r minus 1, which is c. Now just take the LHS. This is the LHS. Replace with the terms here, okay, and then just to simplify. You have to just simplify. What you will get is you will get k to the power of 0 here, okay, and then m to the power of 0 here. Okay, so if k to the power of 0 and n to the power of 0 is 1, correct? So that is nothing but your RHS. So this is how we can prove. Next, if the first and nth term of a GP are A and B respectively, and if P is the product of n terms, prove that P square equal to AB whole to the power of n. Okay, so A and B are first term and nth term. Okay, first term and nth term. So first term is A, nth term is nothing but A r to the power of n minus 1, which is B. Okay, if I do product of this, okay, product of all terms, what I will get is I have A in every term, which is n times, so e to the power of n product. And how many r's I have? R into r square into up to r to the power of n minus 1, which means r to the power of 1 plus 2 plus 3 up to n minus 1, which I can apply sigma n, right? Okay, so a to the power of n into r to the power of n minus 1 into n by 2. Okay, sigma n I am applying on n minus 1 terms. Okay, so now p square is nothing but a square a to the power of 2n r to the power of n into n minus 1. Okay, and which is, if I simplify it further, what I will get is I want to get in the terms of a and b, right? So a to the power of n into a to the power of n into r to the power of n into n minus 1. Okay, now if I take to the power n common here, a into ar n minus 1 whole to the power of n. Okay, so which is nothing but this is a, this is b, correct? Last term. So ab whole to the power of n, that is equal to RHS, hence proved. Next, show that the ratio of sum of first n terms of GP to the sum of terms from n minus 1 to 2n, 2nth term is 1 by r to the power of n. This is a straightforward question again. First series is a plus ar square up to ar n minus 1. So S1, I will call it series S1, nth term is equal to a into r to the power of n minus 1 by r minus 1. Straightforward, right? This is because the initial term is a, common ratio is r. Second series is starts with ar to the power of n, okay, plus this is my n plus 1th term, right, up to ar 2n minus 1, 2nth term. Okay, now my initial term is ar to the power of n, common ratio is again still r. So S2, series 2, sum of n terms is equal to ar to the power of n into r to the power of n minus 1 by r minus 1, which is same. So S1 by S2, if I take it, I'll get okay, this is S1, sum of S1n, okay, sum of S2n. Okay, I'll get 1 by r to the power of n. That's what remains. So this is what we want to prove. Okay, next. If A, B, C, D are in GP, show that a square plus b square plus c square into b square plus c square plus d square equal to ab plus bc plus cd whole square. And it is similar problem. If you take A, B, C, D are in GP, which means A, B, C are in GP, so b square equal to AC, then c square equal to BD, then AD equal to BC. This is also you should note down. AD equal to BC. Okay. So once you know all these things, you just need to take LHS, expand it, and then substitute accordingly. Okay, wherever you want to substitute, you substitute accordingly. Okay, and then you will get the RHS. Okay, this is LHS. LHS if I expand, this is what I should get, and this is RHS. RHS if I expand, this is what it is. I replace accordingly with these three basically, and then I'll get the correct terms, which is nothing but LHS. So RHS equal to LHS. Okay, do it yourself once. Next. Insert two numbers between 3 and 81 so that resulting sequence is in GP. If I insert two numbers between 3 and 81, there are total 4 numbers. So total 4 numbers are in GP, correct? So once you know this, this is very simple. So let those 4 numbers be A, AR, okay, you can see here, right? AR, AR square and AR power 3. These are the 4 terms. Then A equal to 3, okay, which is given because first number is 3 and AR cube is 81. So from that I can easily get what is my R. So once I know A and R, I can tell what are those two numbers. Okay, right? So 3 into 3, which is 9, and 3 into 3 square, which is 27. These are the 9 and 27 are the two numbers which we can insert between 3 and 81 so that all 4 are in GP. Next. Find a value of n such that a to the power of n plus 1 plus b to the power of n plus 1 divided by a to the power of n plus b to the power of n may be the geometric mean between a and b. Okay, what is the geometric mean between a and b, which is nothing but square root of ab, correct? So this is equal to square root of ab. Now you find n. Okay, so that's the problem. Okay, so this is nothing but square root of ab. Okay, this expression. So simple, you take a denominator to the other side, okay, and try to square both sides. Basically you eliminate this square root. Okay, so this is what you will get, and adjust the terms in such a way that you can get things common. Okay, so finally this is what you will get here actually. Okay, so first thing is a n plus 1, a to the power of n plus 1, b to the power of n plus 1. So square is a to the power of 2n plus 2, b to the power of 2n plus 2 into 2 times a b n plus 1. Okay, if you are confused, you can take a to the power of n as, let's say, m, and b to the power of n as some k, and then you can try. That is easily you can do this. Okay, segregation of the terms, which is equal to ab times a to the power of n plus b to the power of n whole square. Okay, so if I simplify everything, what I will get is this expression here. Okay, a minus b into a to the power of 2n plus 1 minus b to the power of 2n plus 1 equal to 0. So which means there are two options. One is a equal to b. Okay, if both numbers are same, then I can insert anything of this type can be geometric mean between these two numbers. Okay, because you will get one only. Finally, you will get a plus b only. Okay, or if a equal to b, or see, the second option is a to the power of 2n plus 1 equal to b to the power of 2n plus 1, right? So if you consider this is two different numbers having same power and equal. Is it possible? It is not possible if the power is non-zero, right? If the power is 0, both are 1, so it is possible. So 2n plus 1 equal to 0, this is the option. Okay, this is the only option. So which means n equal to minus half. This is the answer. Okay, next. Sum of two numbers is 6 times their geometric mean. Show that the numbers are in the ratio of this one given here. Okay, this is also looks simple. First thing is sum of two numbers a plus b equal to 6 square root of ab. So a plus b whole square, which is a square plus b square plus 2ab equal to 36ab. Then this is what the equation I'll get. Okay, now I need a ratio of those numbers, right? So a by b I need. So I will divide this expression with b square. Then what I will get is with AB, sorry, with AB, if I divide, what I will get is A by B plus B by A minus 34 equal to 0. If I consider the ratio of two numbers as x, a by b equal to x, then it will become x plus 1 by x minus 34 equal to 0. So I get a quadratic equation x square minus 34x plus 1 equal to 0. Now x is equal to, which is ratio of two numbers, is this value, which is 17 plus or minus 12 root 2. This is minus my AB. I need to show that this is same as this ratio, correct? So take this ratio, it's a third. So you know how to remove the denominator from the third. You multiply numerator and denominator with the reciprocal, right? Conjugate we call, right? Conjugate, if you multiply, what you will get is 9 plus 3 square, that is 9. 2 root 2 square, which is 8, plus 2 times 3 into 2 root 2, which is 12 root 2. Okay, divided by 3 square minus 2 root 2 whole square, which is 9 minus 8. So you will get 17 plus 12 root 2. Okay, this is what you will get. Okay, so the ratio is definitely the numbers, the ratio of those two numbers is same as this one. Okay, so hence this is proved. Then what is this 17 minus 12 root 2? Okay, what is this one? Okay, that is nothing but if you take the order reverse. Okay, in this expression, come back to this expression. If I take b by a as x and a by b as 1 by x, then also I'll get same value, right? Okay, so which means geometric series has a property that in either way it is in same geometric progression, right? So this is what that means. B by a, if I take b by a reverse of those two numbers, then you will get the reverse ratio, and reverse ratio is same as this value, 17 minus 12 root 2. Okay, so anyway, the answer is proven by this step itself. Okay, next. If a and g are am arithmetic mean and geometric mean respectively between two positive numbers, then prove that a plus or minus square root of a plus g into a minus g are the numbers. Okay, so this is simple. We know that those two numbers are, let's say a, if I take it is x plus y by 2, and if it is g square equal to xy, right? So I need to take this a square minus g square value. So I'll try to get that value. Okay, a square minus g square I want to get. So I'm squaring this one, a square, and g square already there. So my a square minus g square is, okay, is nothing but x minus y whole square equal to 4 times a square minus g square. Okay, and x minus y is 2 square root of a square minus g square. X plus y is 2a from this, right? X plus y is 2a. Now, if I subtract both of them and solve those two equations, I'll get x equal to a plus square root of a square minus g square, y equal to a minus square root of a square minus g square. Okay, this is what I was to prove. Next. The number of bacteria in a certain culture doubles every hour. If there are 30 bacteria present in the culture originally, how many bacteria will be present at the end of second hour, fourth hour, and nth hour? Okay, this is nothing but you are writing a GP. You need to find second term, fourth term, and nth term. All right, so that is very simple. You can do it yourself. Okay, if AM and GM, that is arithmetic mean and geometric mean of roots of quadratic equation are 8 and 5 respectively, then obtain the quadratic equation. Okay, so if let's first say alpha and beta are the roots of the quadratic equation, then alpha plus beta by 2 is given as 8, alpha plus beta is 16, that means, and alpha beta is given as 25. Okay, so 5 square, right? 5 square is 25. Now from this one I can easily obtain what is my alpha minus beta whole square. Okay, which is nothing but alpha plus beta whole square minus 4 alpha beta, that is uh, 14 square. That means alpha minus beta is 14. Okay, once I have these two equations, alpha minus beta is 14, alpha plus beta is 16, then alpha is 15, beta is 1. So the quadratic equation with roots 15 and 1 is x square minus 16x plus 15 equal to 0. This is my quadratic equation. Okay, next. Let's do miscellaneous exercise. Okay. First one is, if f is a function satisfying f of x plus y equal to f of x into f of y for all x comma y belongs to natural numbers n, such that f of 1 is given as 3 and sigma of f of x turning from 1 to n is 120. Okay, sum of first 120 function values is, sorry, sum of first n function values is 120, then find the value of n. Okay, so basically what we need to find is, we need to find what is f of x. Okay, once you know what is f of x, then this is straightforward, right? This is sum of f of x from 1 to n, so we can find out what is n. Okay, and it is given that f of 1 is 3. Okay, so it's simple. you need at least three terms, three or four terms to see what kind of series it is, right? What kind of order they are forming. Okay. Now f of 1 is 3. F of 2 is nothing but I can write it as f of 1 plus 1, which is nothing but f of 1 and f of 1. Okay, which is 9. F of 3 is f of 2 into f of 1, which is 27. So we can clearly see it will go on in a GP, right? Geometric progression. So now 3, 9, 27 and so on up to nth term will be, what will be the nth term? 3 times 3 to the power of n minus 1, n minus 2 or 3 to the power of n minus 1. Okay. So given that this is equal to first n terms, correct? First n terms is equal to 120. This is given, correct? If this is given, then which is nothing but sum of GP is a into r to the power of n minus 1 divided by r minus 1 is 120. Here a equal to 3, r equal to 3. So we will get this value, right? Right? So now we just need to solve for 3 to the power of n or n, right? So 3 to the power of n minus 1 equal to 80 or 3 to the power of n is 81. So n is equal to 4. This is the value. Okay. So first find out the first few terms and then see which progression it is forming, and then we can apply rules accordingly. Okay. Next, if some terms of GP is 315, whose first term and the common ratio are 5 and 2 respectively. Find the last term and the number of terms. Okay, yeah, this is simple. Already, like we have a series here, a plus AR plus AR square up to AR to the power of n minus 1, which is equal to 315. So we know the sum equation, a into r to the power of n minus 1 divided by r minus 1, correct? Which is equal to 315. So if I substitute a equal to 5, r equal to 2, which is given values, if I substitute, what I will get is 2 to the power of n minus 1 equal to 63, or okay, 2 to the power of n is 64. So n is 6. If n is 6, what is my last term? Last term is nothing but a into r to the power of n minus 1, correct? So 5 into 2 to the power of 6 minus 1, which is 5. So it will be 160 is my last term, and total 6 terms and the last term is 160. There are total 6 terms basically. There are total 6 terms and the last term is 160. Next. The first term of GP is 1. The sum of third term and the fifth term is 90. Find the common ratio. Okay, this is simple. You can do it yourself. A is given as 1. A3 plus A5 is 90, which is nothing but AR square plus AR to the power of 4 is 90. So if you take substitute A, you will get a quadratic equation finally. You solve it, you will get multiple values. See which one are applicable. Okay, in this case, R square equal to minus 10 comma 9 it is coming. Okay, minus 10 is not possible, square cannot be negative, so minus 10 is not possible, so you take only 9, r square equal to 9, so r is plus or minus 3. Next, the sum of three numbers in a GP is 56. If you subtract 1, 7, 21 from these numbers in that order, we obtain an arithmetic progression. Find the numbers. Okay, so this involves GP and AP, so do it carefully. AR and AR square are the three numbers I am assuming. So sum of these three is 56, which is nothing but A into 1 plus R square equal to 56. This is my first equation. Now if I subtract 1, 7 and 21 from these three terms, okay, this is what it is. Okay, A minus 1, AR minus 7, AR square minus 21. They are in AP, which means 2B equal to A plus C, right? Neighboring 2. So 2 times AR minus 7 equal to a minus 1 plus AR square minus 21. So this will, from here I will get another equation, A into R minus 1 whole square equal to 8. So these are the two equations. If I divide both of them, I will get 56 by 8, which is 7 for this one. Now I take the common terms to one side and simplify. I will get a quadratic equation, which is nothing but 2R square minus 5R plus 2 equal to 0, which is 2R minus 1 into R minus 2 equal to 0, or R equal to half and 2. Okay, now once I know this one, R is half, I can find out what is my A, correct? So for R equal to half, A is nothing but 32 and the numbers are 32, 16 and 8. For R equal to 2, it is basically reciprocal, so you will get a reverse order, right? Okay, A is 8 and the numbers are 8, 16 and 32. Okay, these are the numbers. Next. A GP consists of an even number of terms. Okay, number of terms are even. If the sum of these terms is 5 times the sum of terms occupying odd places, then find its common ratio. Okay, so this is also simple. Write it properly. That is important. Okay, let the GP be this one, AR square up to AR to the power of n minus 1, n is even. Okay, I should note down n is even. Sum of terms is this one, GP sum. So now series with odd terms. Okay, now you take only odd terms. So there will be how many odd terms will be there? N by 2. Because n is even, n by 2 terms will be there. That is nothing but AR square, AR power 4. So you skip one of the term. Okay, so it will go up to AR to the power of n by 2 minus 1. Okay, so now sum of terms of this one, this series is nothing but A into R square to the power of n by 2 minus 1 divided by R square minus 1. Okay, so it is given that sum of GP terms equal to 5 times the sum of odd terms, right? So that's what I wrote it. If I simplify, this is what I'll get finally. Okay, A gets cancelled. This is r to the power of n minus 1. This is also r to the power of n minus 1. So cancel. So I am left with r square minus 1 divided by r minus 1 equal to 5, which means r equal to 4. Okay, this is the common ratio. Next. If a plus bx divided by a minus bx equal to b plus cx divided by b minus cx equal to c plus dx divided by c minus dx, then show that a, b, c, d are in GP. Okay, how do you show 4 numbers are in GP? You take first 3 numbers, prove that b square equal to ac, take second set of 3 numbers and prove that c square equal to bd. Okay, then all of them are in GP. That's what we'll do now. Okay, so take the first two terms equation, then form the equation, expand it, and then you will get b square equal to ac. Okay, which means ABC are in GP. Similarly, you take second two. Okay, you can prove that c square equal to bd. Okay, which means BCD are in GP. Which means from the above two we can say ABCD all four are in GP. Okay, next. If S be the sum and P be the product and R be the sum of reciprocals of n terms of GP. Okay, so now what is this? You have a series which is geometric progression. S is the sum of that geometric progression of all the terms. Okay, and P is the product of all the terms. R is the sum of reciprocals of those terms. Okay, so prove that P square into R to the power of n equal to S to the power of n. Okay, yeah, this looks something different but very easy. Okay, how it is easy? Reciprocals of geometric progression also in geometric progression, right? With common ratio will be 1 by r, first term will be 1 by a. So if we know this one, okay, now first is sum of geometric progression, this is the formula. Product of geometric progression is nothing but you have n a's and r will run from 1 plus 2 plus 3 up to n minus 1, correct? So r to the power of n minus 1 into n by 2. So a to the power of n into r to the power of n minus 1 into n by 2. Now r is nothing but sum of reciprocals is nothing but 1 by a into 1 minus 1 by r to the power of n divided by 1 minus 1 by r. If I simplify, this is what it is. Okay. Now p square r to the power of n, that is the LHS side if I take and put it here and simplify it, what I will get is a to the power of n into r to the power of n minus 1 whole to the power of n divided by r minus 1 whole power n, which is nothing but sum of terms whole. Okay, s to the power of n. Okay, so this is how we can prove it. Next. Yeah, next question. If ABCD are in GP, prove that a to the power of n plus b to the power of n, comma, c to the b to the power of n plus c to the power of n, comma, c to the power of n plus d to the power of n also in GP. Okay, so this is simple. We know 4 terms are in GP, so we will let them be AR square and AR cube. Now, if you want to prove these 3 terms are in GP, we need to prove b to the power of n plus c to the power of n whole square equal to product of these two, right? So that's all we will do basically. What is a to the power of n plus b to the power of n as per this one, a plus ar, correct? So which is nothing but a to the power of n plus a to the power of r whole power n, which is equal to, if I take a to the power of n as common, 1 plus r to the power of n. What is b to the power of n plus c to the power of n also? I'll take ar whole to the power of n into 1 plus r to the power of n. This is my c to the power of n. So if I take product of the first and third terms, then I'll get the second term. That's as simple as that, correct? So for this, if I form this as a GP, then what will be the GP? Okay, a to the power of n into 1 plus r to the power of n, comma, a to the power of n plus r to the power of n into r to the power of n, then r to the power of n whole square. So my initial term is a to the power of n into 1 plus r to the power of n. Common ratio is r to the power of n. Okay, so you can easily prove they are in GP. Okay. If AB are roots of x square minus 3x plus p equal to 0 and CD are roots of x square minus 12x plus q equal to 0, where ABCD are in form a GP, then prove that this expression. Okay, this is very easy. You can prove it using component on dividendo. Okay, q plus p by q minus p is we can actually get it from q by p, right? So first get what is the value of q by p. How do you get ABCD are in GP? So these are my terms m, mr, mr square and mr cube. M plus mr is 3, correct? Sum of the roots of this equation, okay, which is nothing but m into 1 plus r equal to 3. Then second two roots are mr square plus mr cube. Sum of them is 12. Okay, so mr square into 1 plus r equal to 12. So if I divide these two equations, I'll get 1 by r square equal to 1 by 4 or r square equal to 4. Okay. Uh, Now product of the terms is m into mr equal to p and mr square into mr cube equal to q, right? So p by q is nothing but 1 by r to the power of 4. This is what I wanted actually. Okay, r square is 4, p by q equal to 1 by 4 square, that will be 1 by 16, correct? So r to the power of 4 equal to 16, right? Now you apply component on dividend on p by q. Okay, so it will become p plus q divided by q minus p. That's what we wanted actually as per given this one. So it will become r to the power of 1 plus r to the power of divided by r to the power of 4 minus 1. Okay, which is nothing but 16 plus 1 by 16 minus 1, 17 by 15. That's what is to be proved. Okay, so next. The ratio of arithmetic mean and geometric mean of two positive numbers a and b is m is to n ratio. Show that a is to b equal to m plus square root of m square minus n square divided by m minus square root of m square minus n square. So this is also you can easily prove using component on dividendo. Okay, so arithmetic mean of AB is a plus b by 2. Geometric mean is square root of AB. Once you know this, a plus b by 2 ratio with square root of AB equal to m is to n, which means if I take a plus b by 2 as mk, some constant k, a plus b equal to 2mk, then square root of ab is nk, correct? Same constant, n into k. Now, what I need is a plus b divided by a minus b if I get, then from that I can get a divided by b, correct? So I need a minus b term now. A plus b is already here. I need a minus b. A minus b is nothing but a plus b whole square minus 4ab, correct? So from that I will get a minus b as square 2k into square root of m square minus n square. So a plus b by a minus b is 2mk divided by 2k into square root of m square minus n square, which is, if I simplify, m divided by square root of m square minus n square. This is my a plus b by a minus b. Now if you apply component on dividendo, this will become m plus square root of, this is the denominator here, right? M square minus m square divided by m minus m square minus n square equal to, same thing you apply, do on the other side. A plus b plus a minus b divided by a plus b minus a plus b, which is nothing but a by b. Okay, so this is what we are supposed to prove, hence proved. Next. Find the sum of the following series up to n terms. Okay, so this is a very common question I told you, which will keep coming. So I think we have solved it before. You can try it yourself and solve it yourself. Okay, it's the same way you will do it. Okay, these two. Next. Find the 20th term of the series 2 into 4 plus 4 into 6 plus 6 into 8 up to n terms. If you see here very clearly, there are two series 2, 4, 6 and it's going on one AP, then 4, 6, 8 another AP. Two arithmetic progressions are there in this, correct? So you just take the two progressions differently. First is 2, 4, 6 and the common term will be 2 into n plus 1, 2 into n minus 1 into 2. Second one is 4 plus 6 plus 8. So common term will be 4 plus n minus 1 into 2. Right? Now the general term is Tn is product of these two general terms. Right? So you simplify it, what you will get is, and you need 20th term, right? So n equal to 20, if you substitute, what you will get is 40 into 42, which is 1680. Okay? So this is the answer. Next. A farmer buys a used tractor for 12,000. He pays rupees 6,000 cash and agrees to pay the balance in annual installment of rupees 500 plus 12% interest on the unpaid amount. Okay, how much is the tractor cost? Total cost of the tractor. Okay, so this is simple. Okay, first is how much is the balance amount? 6,000, 12,000 minus 6,000, 6,000. On 6,000, he is paying interest. Correct? Installment amount is 500. And how many months he will pay? 6,000 is a loan, 6,000 by 500. 12 months he will finish the loan. Correct? In 12 months, he is paying 12% interest on the unpaid amount. Okay. So now, what is the unpaid amount? It will be something like this: 6,000, 5,500, 5,000, up to 500. Correct? This is the AP, arithmetic progression. 12% interest on this also will be in AP, because you are multiplying the terms of AP with a fixed number, fixed percentage, right? The 12 by 100 is a fixed number. That is also in AP. So nothing but this is the series I am looking at. 12 by 100 into 6,000 plus 5,500 up to 500. Correct? 12 terms. So this is 12 by 100 into 12 by 2. 12 terms, right? Total. So 12 by n by 2 into first term and last term. 6,000 plus 500. Correct? This is Sn equal to n by 2 into a plus l. This is what I am applying. So total interest is equal to 12 by 100 into 6 into 6,500. Okay, 6 into 6,500. So if I simplify, I'll get total interest as 4,680. Okay, now total cost of the tractor is 12,000 plus 4,680, which is 16,680. Okay, this is the total cost of the tractor. Next. Shamshad Ali buys a scooter for 22,000. He pays 4,000 cash and agrees to pay balance in annual installment of 1,000 plus 10% interest on unpaid. It's exactly same problem as before. So do it yourself. Okay. Check the answer. Next. A person writes a letter to four of his friends. He asks each of them to copy the letter and mail to four different persons with instructions that they move the chain similarly. Okay. Basically, it's a chain mail. First person writes to four persons and each person will write to other four. So the chain will keep on going on. Okay. So this is a clearly you can say it's a geometric progression where first person, then four starts with four, right? And then uh, multiply by four. Okay. The common ratio is four. Okay. And chain is not broken. It costs 50 paise to mail the one letter. Okay. Then if eighth set of letters are mailed, what is the total cost? That is what is question. Okay, so basically you need to find what is the eighth term and then multiply with 50 paise, right? Because one letter cost is 50 paise. Eighth term, how many are the total letters? That's what we need to find out. Each set of letters are in GP as below. 4 into 4, comma 4 into 4, comma 16 into 4, right? Each time it is multiplied with 4. 8 sets. So 4, 4 square, 4 cube, up to 4 to the power of 8. Correct? That is my 8th set. First set is 4 to the power of 1. So 8th set will be 4 to the power of 8. So this is a GP where A equal to 4, R equal to 4 and N equal to 8. Okay, so S8 equal to A into R to the power of N minus 1 divided by R minus 1. This sum rule if I apply, what I will get is 87,380. So many letters by 8th term itself, there are so many letters. Okay, so many total letters were sent. So cost of each letter is 50 paise. So total cost will be 87,380 into 50, which is 43,690. So many rupees. Okay, next. A man deposited 10,000 in a bank at the rate of 5% simple interest annually. Find the amount in 15th year since he deposited the amount, and also calculate the total amount after 20 years. Okay, so this is carefully read the words. Okay, simple interest of n terms is PTR by 100 or PNR by 100. Okay, 15th year of deposit means 14 terms are there. Correct? 15th year there are only 14 terms, not 15. Correct? Amount in 15th year you want to know. Means 15th year is not yet completed. 14 years are completed. Okay. So that is interest is nothing but 10,000 into 14 into 5 by 100, which is 7,000. This is very important to note down. Now, total amount in 15th year is 7,000 plus 10,000, which is 17,000. Now, second part is what is the total amount after 20 years? That means N is 20 now. Terms are 20. After 20 years, so number of terms after 20th year is 20. So total is equal to 10,000 plus 10,000 into 20 into 5 by 100. Okay, the here it's not 14, it will be 20 now. Okay, 15th year it is 14, but after 20 years, that number of terms is 20. Okay, so if you do this, you'll get 20,000. Okay, that's the answer. Be careful with the terms. Okay, next. A manufacturer reckons that the value of machine which costs him 15,625 will depreciate each year by 20%. Find the estimated value at the end of 5 years. So it's a depreciation question. So R is minus 20%, which is uh, minus 5 by 100. Correct? 20% is minus 1 by 5. Or okay, okay. So minus 20 by 100. Sorry, this is 20 by 100. R is. So after 5 years, it will be, you can apply compound interest formula. Okay, 15,625 into 1 minus 20 by 100 into whole to the power of 5 terms, right? And each year it is 20% depreciation. So you can apply a compound interest formula. So P into 1 minus R by 100 whole to the power of N. That's what I did. So the value at the end of 5 years will be 5,120. Okay, next. 150 workers engaged to finish a job in certain number of days. 4 workers dropped out of the second day, four more dropped out of third day, and so on. It took 8 more days to finish. Okay, if 150 workers worked together, they will finish in n number of days. But if 4 workers are dropped every day, then it took n plus 8 days. Okay, this is what you need to understand from the question. Find the number of days in which the work was completed. What is n plus 8 is asking. Okay, how many days this is completed. Okay, so number of percentage, if it is completed normally is 150 into n. If n workers are there, 150 into n. Correct? Sorry, if it is finished in n days, it is 150 n. This is the total amount of work. Correct? Total work is 150 n. So even if you apply the second way, you should get to 150 n. Now, with this given plan, work is done in n plus 8 days. In n plus 8 days, every day 4 workers are reduced. Okay, so first start with 150, then 150 minus 4, 150 minus 2 into 4, 150 minus, and so on. 8 terms, 8, right? N plus 8 terms. So if I apply this arithmetic progression sum, so this is nothing but sigma of n equal to 1 to n plus 8, 150 minus n minus 1 into 4. Correct? Which is nothing but n by 8 by 2, n by 2, right? So n by 8, n plus 8 divided by 2 into 2 times a, which is 150, minus n minus 1. N is nothing but n plus 8. So n plus 8 minus 1 into 4. Okay. So if I simplify this and equate it to 150n, this is the total work. Okay. I get a quadratic equation. And if I, what is that? 136 minus 2n into n plus 8. Okay. So this is what that is. Okay, which is equal to 150n, right? Now, if I simplify, I'll get a quadratic equation, which is n square plus 15n minus 544 equal to 0, or n minus 17 into n plus 32 equal to 0. So, n is either 17 or minus 32. Number of days cannot be negative, so 17 is the number of days. So, if total number of days is 17, if it is completed in normally, then n plus 8 days is 25 days. This is the answer. Okay. So carefully do these problems. Okay. Next. Yeah. So these are the miscellaneous questions. Now there is no harmonic progression mentioned in the NCERT book, but these are the things, basic things you should understand. Okay. If ABC are in harmonic progression, then 1 by A plus 1 by A, 1 by B, and 1 by C are in AP. Okay. Example is, if 1 by 2, 1 by 4, 1 by 6 are called in arithmetic progression because 2, 4, 6 are in the denominators are in AP. Okay. If A, B, C are in HP, then 1 by A, 1 by B, 1 by C are in AP, which means, okay, which implies 2 divided by 2 times B, correct? If these are all in AP, 2 times middle term equal to sum of neighboring terms. So 2 by B equal to 1 by A plus 1 by C. If I simplify, this is what my harmonic mean, correct? B equal to 2AC by A plus C. This is my harmonic mean. Okay. So this is what the harmonic progression. You will solve the harmonic progression problems using arithmetic progression only. Okay. But only final answer will be reciprocal. You will get. Okay. Now to understand arithmetic mean, if AB are two numbers, then arithmetic mean is A plus B by 2. Geometric mean is square root of AB. Harmonic mean is 2AB by A plus B. Okay. So for any positive numbers, arithmetic mean is always greater than or equal to geometric mean and always greater than or equal to harmonic mean. Remember this. Okay. Most important inequality rule. Okay. And this equality is applicable only if all the numbers are same. That you have to remember. Equality is possible only if the numbers are same. If A equal to B, only then this is possible. Or A equal to B equal to C. Whatever is the number of numbers you are taking. Okay. 3 numbers, 5 numbers, 10 numbers. If they are equal, then equality is applicable. Otherwise, no. Okay. Now, another thing to note down is this is applicable only for two numbers. If you are taking geometric mean, arithmetic mean, and harmonic mean of only two numbers, then geometric mean equal to arithmetic mean into harmonic mean. Okay, remember this. This is useful uh, to solve many problems actually. And note down there is a condition very clearly mentioning it is applicable only for two numbers. If it is more than two numbers, you are taking arithmetic mean, geometric mean, and harmonic mean, then this is not possible. Okay, this is not. Definitely no. Okay, this is possible only for two numbers. Okay, note down these properties of harmonic progression. You can solve the problems of JEE and BITSAT and other engineering entrance questions, and I will start videos of those also. Okay, so thank you. This is series and sequences. You can watch my videos coming up videos on these topics. If the problems are complex, then I will make a video. If the problems are simple, I'll make short. Okay. So, till then, keep doing maths. Thank you.